It's your friendly math tutor, Miss C here, and today we are determining if a table represents a linear function, an exponential function, or neither of these functions. So let's go ahead and get started. So the first thing I'm going to notice about all 5 tables is that our x values are exactly the same. They all increase by 1. So that means for today's purposes, we only need to look at the y values. So sometimes when I am looking at tables and I see fractions, I like to start in the non-fraction part. So if I'm going from 4 to 12, right, I could look at this as we're growing by an addition of 8, or this could be multiplication by 3. So if this is linear, we would see this growing by 8 again. 12 plus 8 is not 36, so this cannot be multiplication. Or addition, I'm sorry, but 4 times 3 does equal 36. So if we look at this one, is 4/3 times 3 4? It is. And is 4/9 times 3 4/3? And it is. So this table is growing by a factor of 3 every single time. That means this is exponential. So remember, exponential functions, their growth is multiplied, or it grows by a factor. All right, let's look at this table. I'm looking at this and I'm going to say this looks like it's growing by 6, or it could be maybe growing by a factor of 7. This one here is growing by 7 plus what equals 17 is 10. But 7 times 7 does not equal 17, so we know that it's not multiple. It's not a factor. And then we see that we are growing by, what is this? 17 plus 10 is 27. Plus 4 more, this is growing by 14. I'm noticing that each one of these is growing by 4, so I think this one is growing by 18. This is not linear, and it's definitely not exponential, so this is neither. For those of you who have studied quadratics, if you're thinking that is a quadratic table, you're absolutely right, but that is for another video because we're only looking at linear and exponential functions today. All right, let's look at this one. Going from 18 down to 13, I'm going down by 5. Then I'm going from 13 down to 8. I'm going down by 5. 8 to 3, going down by 5. 3 to -2, I'm decreasing by 5. We have a constant rate of change, a decrease of 5. That means this is linear. That means this function would have a slope of -5. Here we go again. We are going from -16 to -13. That's actually getting bigger, right? Because we're getting closer to 0. -13 to 10, we're getting bigger by 3s. We're growing by 3 here. We're going by 3 here again. This is also a linear function with a slope of +3. And finally, we've got some big numbers on this one. This looks like we're dividing by 4. To go from 1600 divided by 4 gives me 400. I'm dividing by 4 again to go from 400 to 100. To go from 100 to 25, I'm dividing by 4. And if I put 25 divided by 4 in my calculator, I actually get 6.25. So I've got division by 4, but I want to think mathematically. I'm going to use my number sense. I know that dividing by 4 is the same as multiplying by 1/4. So if I multiplied all of these values, 1600 by 1/4, I get 400. 400 times 1/4 is 100. It's the same as dividing by 4. That means that 1/4 is my common factor, and this table represents exponential decay. We're getting smaller, and this one is exponential growth, okay? And that is how you determine if a table represents a linear function, an exponential function, or neither. Make sure to subscribe for more videos. Till next time, remember, you've got this.